The other one that it oftentimes surprises me is people don't think about parallelism when they start. They're not thinking about how is this going to scale in terms of the processing that I'm doing. Can I shard it across multiple instances of database, multiple instances of storage, multiple instances of GPU? Am I thinking about how much memory I have to move back and forth between machines? Because ultimately, so our engineering team builds parallel systems, but every time it's funny, every time we get a new client, the first thing that happens is they complain about how slow it is, because if you buy something new, that's what you do. Like, I wanted it to be faster. And usually it's because what you're doing is a little different, or you're not used to how to use it or whatever. But if we find issues on our side, it's oftentimes because there's a bottleneck in either a piece of code or how we're sharding something. We thought, oh, we never thought about sharding it in this way and at this granularity, because it's hard to think in terms of parallel programming. It's hard to implement something that can scale as the programming scales. But oftentimes I don't know if it's the platform services team or the data architecture team at a lot of these research institutions, they'll take what the scientists, like part of their job, besides sort of managing infrastructure and making sure that they have services available, is to help the end user developers, scientists, researchers, whoever it is, to help them understand, okay, how do I get the most out of what I'm using? Yeah. Because if you run a job, if you have 10,000 GPUs at your disposal, but everything you're running ends up bottlenecking on one, then what's the point?
Yeah, why have 10,000?
So that